In this brief video, I want to talk about the vector equation of a line, or a line written in scalar product form. So this is a little bit different from the equation of a line that we've seen before. Well, on the screen now I've got the way that we've written an equation of a line when we've got it in vector equation form. So let's just recall each part of this. R here is just, if you like, x, y. So just any general point on the line. A was a point on the line, a specific point on the line. B is the vector going in the direction of the line, and the lambda here is some constant. So 2 or 3 or a half or 4 or anything like that. So they're the different components that made up the equation of a line. Now what we want to do is look at a different way of looking at the equation of a line. This way uses the dot product, or the scalar product. Now for any line that we've got here, the direction of the line and the direction of the normal to the line, so this direction here, so a vector that is normal to the line or perpendicular to the line, that will always be the same vector, won't it? So I could talk about this vector, I could talk about this vector, but any vector that is normal to the line will just be a multiple of that. So we might have this vector, we might have another vector that's twice as long. But in any case, the dot product between any of those three vectors that I've written that are perpendicular to the line, the dot product between them and the direction of the line going in is 0. So that's another way that we can write the equation of a line. So let me get rid of those. The letter that we normally use for this vector here is n, the normal to the line. Okay, so that's what that n is. It means normal, and it means a vector that's going perpendicular to the line. Okay, so A is a specific point on the line here, and R is a general point on the line. So any point x, y, and B is going in the vector in the direction of the line. So let's check this out. If we go from A to R, we know that to go to any 2 points, it's just R minus A, where R and A are the position vectors of the point R and the point A. Okay, so what we're saying is that this vector, the dot product of that with the normal to the line is equal to 0. And that's true, because AR is in the direction of the line, N is the normal to the line. We know that when the dot product is 0, the angle between the two vectors is 90 degrees. Cool. So what's A to R? A to R is R minus A, where they are the position vectors of those 2 points. Okay, now we can do a little bit of algebra here. We know that when we've got brackets, the dot product works nicely where we can expand the brackets. So this is R dot n minus A dot n equals 0. And then a little bit of rearranging. R dot n equals A dot n. And that looks really confusing, but that is what we'd say is the vector equation of the line written in scalar product or dot product form. Or sometimes we might say it's in normal form. So let's break down each of these components to make sure we understand it. R is any point, general point on the line. Okay, so that's what R is. So like x and y in this case. N is the vector that is normal to the line. A is a specific point on the line, and again, N is the normal to the line. So let me show you how that works in a question. Find the equation of the line that's perpendicular to that vector going through that point. Okay, so rather than having what's the equation of the line that's going in the direction of the line, this one's going perpendicular, and particularly for these kind of questions, this formula works really nicely. So let me write it out again. R dot n equals A dot n. Okay, let's put in what we know. R is any general point on the line, we don't know that. We know the normal to the line is 3i plus j, so I'll write it like this, 3, 1. A is any point on the line, and in this case we're given what A is. It's going through the point 4 minus 1, so that's what A is, the point on the line. And n again is 3, 1. There we go. So we've got R dot 3, 1 equals. Now on the right hand side we've got the dot product, so we can do the dot product. 4 times 3 plus minus 1 times 1. So that gives us 11. Okay, and we can leave it like that. That's the correct answer. That is the equation of the line in this new form, r dot 31 equals 11. That defines one specific line. Now, if we remember r is just x and y, we could write it like this, xy dot 31 equals 11, and then the dot product on the left-hand side gives us 3x plus y equals 11. So from this form, we can also get the Cartesian equation of that line, which is neat as well. So that is how to get the equation of a line in this vector product, this scalar product or dot product form.